In this lesson, we'll continue our discussion of probability distributions and we'll shift from discrete distributions to continuous. So let's look again at the Zippy Bright problem, and we're going to move upstream now from sales at stores up to their distribution centers. And so let's assume they have three distribution centers, and the east, the center, and the west. And in the eastern distribution center, they serve 3,500 stores. And what I'm showing in this data table is the weekly demand or sales of the XP219 for each week for the Eastern DC. And so the question is, what can we say? How can we characterize this distribution? What can we say about this data? Well, hopefully you have some ideas of how you would do this, and to help you, here are some spreadsheet functions. Spreadsheets are great tools for just quick analysis. And so there are many different tools out there. Most people either use Excel, Google Sheets, or LibreOffice. Excel is widely used, the most commonly used spreadsheet. Google Sheets and LibreOffice are free. So whichever you want to use, they're fine. They're all equivalent. And so what I show here are for the different functions: minimum, median, mode, the mean, the maximum percentile, and the variance and standard deviations, the specific functions you need for each of the spreadsheets. And if you look at this just really quickly, you'll see they're very, very similar. Now for percentile, for Excel it has a K value, for Google Sheets it says percentile, and for LibreOffice it says alpha. That's actually whatever percentile in decimal form you want to show for the distribution, such as 0.75 for 75th. And then the other point I want to make is the difference for the variance and standard deviation between a population and a sample. Now I'll talk more about this in a later lesson, but essentially everything I did in the first lesson this week assumed that everything was a population. It was all that's there. In real life, though, you don't necessarily know the true mean of a population. Instead, you have a sample that you're taking, and then you have to estimate what that mean is by using one of the observations, right, in that data. So what you have to do, an unbiased estimator for this, is the S squared. It's the sample standard deviation, or the sample variance, and you have to divide by n-1 instead of n. It's a technical reason, but essentially what it's doing, because I have to calculate or estimate the average, I'm using one of my degrees of freedom. And so now in real life, you should just always use the sample. And it's the default for most of the spreadsheets. If you don't specify, it'll assume that you want the sample standard deviation or the sample variance. And if you think about it, as n gets bigger, right, then the difference between these gets very, very, very small. A rule of thumb is above 32, above n equals 32, they're almost equivalent. And if you have data with thousands of observations, then they're really indistinguishable. However, if you use this and get some summary statistics for this weekly demand for the Eastern DC, sort it if you want, you should get numbers like this. There's a minimum value of about 2,000, the median of 2889, a mean of 3,022, and you can see the rest of the numbers. So the question is, should I treat this as a discrete distribution? How should I handle this? Or should I try to treat it as a continuous distribution? Because if we look at this, one of the things we'll observe is that there are very few, in fact no observations, no weeks that are identical. They're all different. So the question is, how do I handle this when the number of possible observations gets really, really big? And that's what we'll cover next.